Amazing people. Today we're beginning to look at probability density functions. Now, when we're dealing with probability density functions, first of all, we need to understand the type of probabilities we're looking at here. Now, this is dealing with continuous probability. Continuous probability is the type where the data you're measuring can have a range of values. It's not going to be set values. So as an example, you might think about the number of balls caught or something. Okay? It has to be a whole number there. So that's not the type of data we're dealing with here. What we're dealing with is the data which can be continuous. It's on a moving scale continuously. So if you think about measuring somebody's height, it could be 150 centimeters, but it could also be 150.1 centimeters, 150.2 centimeters. It could even be even more narrow than that and be 150.05 centimeters or 150.0025 centimeters. There's no restriction on what the data values can be. And so what we're seeking to do here is we're seeking to find a way that we can group this data and understand it better. Now, in doing so, we use these probability density functions. And this is useful. It's effectively, in a way, grouping data together. We can take individual values, because you could have surveys of 150 people. And because it's continuous data, those 150 responses you get could all be different. So it's a bit hard to group things together. So what we're seeking to do is have a way of understanding that. Now, the first thing here is you can see on this graph, we've got a whole bunch of data. Now, assuming each of the square columns here, these are acting like grouped data here. So we might say it's of a range between 1 and 2, but the next one would be on a range between 2 and 3, or something like that. Now, essentially, we're just grouping data together. But what I want you to pay attention to here is pay attention to the orange curvy line here. Now, this is going through the center of each of these columns, but it's creating a graph for us, which helps us understand the patterns a little bit more, and helps us with being able to recognize the patterns which are occurring, and also be able to work on totals and where there's groupings. Now, this may look a little bit like when you start integration, where you have your columns and you use columns where you break up the area under each graph into different parts. And now, one of the key things with this is you can see here this graph has been labeled as P of X. Now, there's a few ways of doing this. It can also be used as F of X. All this is doing is trying to represent the data which we have here. Now, one of the other key things here is we're only looking at the space above the x-axis. So it won't ever dive below the x-axis. That won't happen. It will only be space which is shown above the x-axis. So space up here. That's the type of thing we're looking at here. So we're only looking at those positive y values we're getting from these equations. Now, one of the key things to consider here when we're looking at these probability density functions, we'll consider this point here, which I've drawn in red. Okay, this point here, if I had to find the area or a number for that using integration, I wouldn't get one because my width here would be 0. So what we do need to do instead is we need to be able to have a better way of doing it. So what we do is we define what areas we're finding under here. So I might say I'm finding it between these two areas here. So it gives us this shaded in region we're looking at. Now, this shaded in region here, this will represent the area we're trying to find here. And so we do this by giving the first one a designation of A and the second one a designation of B. So if we did have to find the area or the total amount under this curve, we would classify this as being between A and B, F of X, and we would integrate that to find the area here. Now, one key thing when we're finding areas, with all probabilities, there's always, when you take into account all the possible outcomes you can have, there's only going to be a result of 1 when you add them all together. 1 representing 100%. So it's all possible outcomes. There's nothing else there. And so when we're doing this, if we were to take the total area under a curve, or in this case, a probability density function, this then would then have a area of 1 underneath, saying that the probability of all results occurring is going to be 1. There's a 100% chance that one of those results is going to occur.